Okay, so it's all about salting on Spark. So here is my Spark, and I'm gonna add salt to it. Okay, so let's discuss about what is salting.
Hi, welcome to the Data Tech. So today we are going to discuss about salting in Spark. So salting is actually a topic. I can say this is a solution. So what is the problem then? So problem, it's about data skew. Okay. So first we have to see what is data skew and how it occurs. Okay. So once we get to know these two, and then we can go for the solution, salting. Okay. So data skew is all about a particular partition in your cluster has more data compared to the other partition for the given input file. Now imagine that we have our own drive in laptop. So let's take an example. Let's consider our laptop drive, hard drive, got splitted into three partitions, right? C drive, E drive, and F. So if you see here in my F drive, it's already red. It's almost done. My entire disk space, which is allocated for this particular F drive, is almost completed. So if you see, this is called a skew. Okay, one particular partition of my drive has more data compared to the remaining two. So just imagine you may get a question in your mind, but for C drive you have allocated 500 GB. It's 1 TB hard disk in total. So just imagine that the hard disk has been splitted equally. Just imagine that way. Okay. So now in that case, like F has red because it has a lot of data compared to other two partition. Now if I trigger some job on top of this F, right, will take long time compared to my E drive and C drive. Maybe in E drive and C drive job completed, the task of the job completed in 10 minutes. Maybe this F drive, the same job, but different task of the same job can take like 30-40 minutes also, which is long running. So that is where the skew comes into picture. Now you can ask me like how I will know that whether my job has skew or not. So for example, you are running a Spark job, and then you could see in your web UI, Spark web UI, where like 4 different tasks are running. 3 tasks are already completed, but in one task it got stuck. So and that means like the remaining 3 has completed already, but still this particular task of the same job is running this much time, then we can suspect that there could be some skewness in our cluster. Fine. Now here let's discuss, like I have 4 nodes in my cluster. Let's consider HDFS. Okay, now let's consider this as HDFS. So now you are trying to upload a file to your cluster which is around like 80 GB. Okay, so in first node like 10 GB is getting stored, and second node again 10 GB is getting stored, and third node 10 GB, but in fourth node 50 GB file has been get stored. So it tries to distribute the data as much as possible equally, but due to some resource problem, like the first 3 nodes are already occupied like 80% of disk space. So the last node has more capacity, so it's just uploading most of the, like almost like 60% of data in the fourth node. Now, when you run a job on these 4 nodes, right, the tasks which is running on these 4 nodes, the first 3 node task will be get completed soon because it has only 10 GB of the data. The last node may take a lot of time because it is 50 GB has been get stored, and where it ended up with long running, and we call it as a skew. So this is one scenario of skew. Now let me tell you another scenario of skew. Let's consider the Hive table or any other SQL. So you create a partition on country column. Okay, so you create partition on country column. So that means one partition create for India, US, and UK. Right. So unfortunately, you are getting more volume of data to Indian partition. Like you are getting 500 GB of data for India, and for US and UK, you are just getting only like I can say hardly like 100 GB of data. Now, in the previous scenario, it's all about disk space. Fine. Okay. So the last node has all the data. It's something reasonable. It's fine. But when you take here in Hive case, anyhow, the partition of records which belongs to India supposed to go to Indian partition only. There is no other choice, right? Even one particular partition in this case having more volume of data will again give you the problem of skew. Now, what happened internally with respect to Hive or any other query engine? So it just checking like this country column value is coming as India. So obviously it has to go to India. Now here comes. So now what they are doing, like they are taking records, like imagine 1, 2, 3, there is 4 India records. Okay. It's 4 India records. So they are trying to apply a salting technique that will create different value for these four records, some random numbers. Just imagine I'm just adding a random numbers to this key, and based on this random number I'm just doing a repartition. Okay, I'm just doing a repartition based on this random numbers. Okay, so now with this random number I'm saying like you have to repartition with 3 or 4. I'm just giving repartition count as 3 or 4. Now it tries to split this India records in a different partition. So we are trying to get rid of the skew. So here in Hive scenario, the skew is reasonable, highly reasonable. It's not because of the resource. That is the previous scenario. In the Hive case, all these record that comes to India only, obviously, right? That is where, like in Hive, people used to go for buckets when the partition is heavy. Then people used to go for buckets. So internally, what bucket does is like it is actually trying to get rid of the skew by creating small buckets for the same partition records. Okay. Now in Spark, right? When you consider Spark, so Spark internally, right? So Spark internally uses hash partition to decide which record has to go to which partition. So I have already made a video for this hash partition. It's recommended for you to watch this hash partition video before you continue to the next level of the same topic. Okay, so the video link is there in the description box of this video. So by default in Spark, it does hashing mechanism to identify which record has to go to which partition. For example, in Spark, you have given 4 partition and you have like 100 records, means for each record, it will take first record and then Spark runs hash partition on top of the first record and it will decide go to partition number 3, P3. And then next we have some 57th record that again does with hash partition and it decide go to P2, partition number 2. So totally 4 partition. So this hash partition has its own formula to derive this number P1 or P2 or P3, which particular partition it has to go, right? So even in that case, the skew can happen. Imagine that for all like almost like 70 records you are getting same hash value, means then it all goes to one particular partition. For example, P2. Okay, all 70 record has getting same hash value. Right, even in that case, it goes to P2. Whereas in Hive scenario, I said partition. In Hive, partition is all about custom partition. You are deciding a column India means go to India partition. But here, when it comes to Spark hash partition, it is not like that. Even like this 70 records, it includes US record, UK record, Australia record, whatever it could be, because here the hash value is the partition. The hash value decides the partition, right? That is a key, because here now we are not deciding based on which particular column like India or Australia. No, hash partition, hash key can be same for UK record as well as US record as well as the Indian record, right? Because that is what the default partition mechanism of Spark. So here the thing what we are discussing is how to get rid of the skew by applying the solution called salting. Okay, so we have the topic, a concept called custom partition and hash partition. So that is different. So where we decide like I have to decide which particular partition folder the output has to go. That means custom partition. You can decide if it is India, go to first partition, go to second partition if it is Australia. Okay, so the default hash partition will take care, it's like it takes the placement, partition placement on its own by doing this hashing mechanism. So what I'm coming to say, even if it is custom partition or even it is based on the hashing in Spark, okay, the skew will still happen is what I'm coming to say. Okay, even if you write a custom partition, if large amount of data comes to Indian partition, then it goes to Indian partition only. Even the case when you have written a custom partition, I'm saying. So even if you go for the hash partition, where the partition is completely decided by Spark by based on the hash key, even in that case, like more than 5 to 6 countries key hash key can be same, so it can ended up with the same partition. So anyway, the skew is going to happen. So this skew thing, salting and skew, is one of the most important challenges that we face in the real time, and it is one of the most important question even now people are asking in interview. Okay, fine. So now in Spark 3, now we have Spark 3, the skewness has been somehow handled by Spark itself, but still, right? So we still, people are asking this question, and people who use lesser version are still facing this as a challenge, and then they are applying salting kind of technique to get rid of the skew. So what overall I'm trying to explain here is what is skew, right? And then like how it can occur. So the reason it can occur is like when you have heterogeneous cluster, that means each and every node has a different configuration of RAM, different configuration of hard disk, this skewness can happen. So that is the scenario one which I explained, that is due to resource. And the second thing is, even though you created a proper partition algorithm to decide which partition it has to go, either in Hive or Spark, you are deciding the partition by writing a custom partition. Even in that case, if more data comes to same partition, then the skew will still happen. Okay, so this is the reason of skew. Okay, two reasons I told you and two scenarios we have seen. Okay, one is the scenario with respect to resource, and another one is the scenario with respect to writing a custom partition or the default hash partitioner of Spark. And Hive I just added as an example for you, right? So now let's get into the solution. So what is the solution that we have with respect to avoiding the skew? So we have two solutions. So one is salting, and the next one is broadcasting. So broadcasting is one of the solution, but the thing is broadcasting tries to keep the the file in memory of each of the executor which is performing the operation, the task, right? And it is quite expensive to use broadcast as a solution for skew. That's why people used to go for salting. Now coming to the salting, so I told you somewhere like in the previous diagram, I told you like here, right? So the random numbers, generating random numbers is what salting I said. Yes. So we are generating a random number, and based on that random number, we are asking the Spark to do a repartition. Okay. So it doesn't mean like whether the record is part of India, UK, US, that doesn't mean. I am just creating a random number for each of the records, and with that random numbers, I am doing a repartition again. And so that I am trying to avoid skew for some percentage. There is no 100% you can remove skew. No, it's not like that. You cannot remove 100% skewness, but you can try to reduce the skew data by doing a repartition so that your task can run faster. Okay, so salting is one technique which is there even in HBase also. In HBase NoSQL database also we perform salting based on adding a auto generated row numbers, and with that we do a partition kind of thing, right? So now here let me jump into the practical to show you how to do this in practical. Okay, so let's get into the practical. I'll just give you a walkthrough on the code. So first we have to, I'm going to use PySpark for this. So first I'm going to import this Spark SQL function. I need two functions here, call and rand. So because I'm going to use a random number, right? So I created two data set, custom item, which has two columns in each of this data set. So which is ID and the name. In the second data set, it is ID and product. So ID is a join key. I have to join this and I have to get the name and the product which they are purchased. Right. Now I'm converting these two data set to a data frame by giving a column name for it with a schema. And then I'm declaring a variable called a num partition equal to 4. And what I'm going to do with this is, so the next line, df1 underscore salt equal to df1. So which is, I'm doing this salting only for my first data set. Just imagine we got this skewness problem only on the first data set, but not in the second. Just imagine. As I told you, how can you identify that I have a skew? Generally, we have to run a job. If it takes more time, a particular task, then we have to think, okay, there is a skew in it. maybe kill and restart sometimes, like people used to do. And even after that, like it has more shuffle read. If you see more shuffle read on that particular task alone, then obviously we have to do a repartition. And when it takes long time with lot volume of data in the shuffle read, then we have to think, okay, it is a skew. Fine. So now I'm doing in line number 11, df1 dot with column. I'm creating a new column name for the random number generation, right? So a new random numbers I'm going to generate for each record, and for that I'm creating a column name. So how I'm going to generate the random number is random function into multiply that with the number of partition, which is 4. Okay. So now cast int. So next I'm going to apply the repartition function on this df1 salt dot repartition num partition. So repartition with what is the value for the repartition? 4. And then the column for the repartition is based on which column is salt. So the column name is wrong here. SALT underscore column. And then now I'm going to do a join. So join ex equal to re dot join, because re which holds my data frame 1. And here I'm not doing anything with df2. So as I'm passing df2 comma, on what condition the join is based on id. Now join ex dot show. Now I'm going to run this. Once I run this, you will see the column, the additional column what I have added and how the value has come. By seeing the output, you will be getting the clear idea. Okay. So now you can see here, right? So Gautam, it goes to 0th partition. Nandu and Sri, these two record goes to first partition, and Saravana goes to second partition, Nila goes to third partition. So there is no skew here, right? So each of the record, most of the record, like 80-90% of record skewness has been reduced here. Only you can see this Nandu and Sri goes to first partition, one partition, because we have given only 4 as the partition repartition count, right? So this is how like we are trying to get rid of the skew thing. Now you can even populate skewness on this same example. You can create skewness. Let me show you that. So I'll show you that. So here, instead of repartition 4, let's change this to 2. Okay. I will run this from 9 to 14. I will run it again. Okay. Now it will be a skew. I'll show you. You can see here Gautam, Saravanan, Nila, Shri. All these 4 records went to one partition 0, and then Nandu went for one partition 1. So here 0 the partition got skewed, right? So that is what. So this with the same example you can create skew, and you can get rid of skew also with the same example. So the magic happened here is based on the partition count that you have given. So that is the main point here. So with the same example, I've just showed you the skew problem as well as how to get rid of the skew. So this is still now asking question and interview. That's why I just wanted to make this video. And if you want to get the complete big data free course, I've made a free course for 17 hours of big data as part 1 and part 2 video. I have given that link also in the description box. If you want to have a complete big data course thing you want to learn, you can make use of it, and please forward this to your friends and colleagues who need this course video as well. And thanks for watching, and please do subscribe channel. And my LinkedIn and Instagram I have given in the description box of this video. Thanks for watching.